that whatever we have studied, differentiation. So what is the use of differentiation? Okay, so basically slope, topic is slope. Like suppose this is y axis, this is x axis, and there is a line. So slope means inclination of the line. Okay, like here you can see, if I make this angle, write this angle theta. So if we have two lines, this is line number 1 and suppose this is line number 2, correct? Line number 1, line number 2. So definitely you can see this line number 2 is more inclined, correct? Suppose you think that this is the ground. From the ground level, this line number 1 is inclined this much and line number 2 is inclined this much. Okay, so we can say that line number 2 has more slope, correct? So slope basically, just physical meaning if you want to understand, so it is the inclination. Correct? And mathematically, slope we write tan theta. Tan theta. So this is the formula for slope. If someone asks what is the slope of line 1, so tan theta 1. What is the slope of line 2? So tan of theta 2. Correct? You can see also, like see, theta 1 is suppose 45 degree. Suppose someone asks what is the slope of line 1. So slope of line 1, what we will write? Tan of 45 degree. What is tan 45? 1. This theta 2 is more, you can see, this is clearly visible. So suppose this theta 2 is 60 degree. Just example I am taking. So if someone asks what is the slope of line 2, so slope of 2 will be tan theta 2 means tan 60 degree. And what is tan 60 degree? Root 3. What is root 3? 1.7. See, slope of this line is 1, slope of this line is 1.7. So slope is increasing now. So second line we have more slope, first line we have less slope. So slope equals to tan theta, directly you remember. Slope we denote by letter M. Write fast. Okay. Now see, if they give like this, that this is y and x axis and this is any line which is having some slope, so slope will be what? Tan theta, and tan theta will have some fixed value, like tan 45 degree 1, tan 60 degree root 3 1.7. So this slope is having fixed value. So these kind of slope, now these are called constant slope. Slope is constant. Slope is not changing, slope is constant. Correct? Moreover, here slope is constant as well as slope is positive. Slope is constant as well as slope is positive. Always remember that if we have these kind of lines, slope will be positive also. So I am writing slope is constant as well as positive. Correct? But if you see these kind of lines, like if they make these kind of lines, then slope will be negative. Here slope is constant because it is not changing, but slope is negative. Slope is constant as well as negative. See, from x axis, this is positive x axis, you measure, and if theta is between 0 to 90 degree, so slope will be positive. So if theta is between 0 to 90 degree, okay, so slope will be positive. But if theta is between 90 to 180 degree, like see na, from positive x axis, like this is positive x axis, if I measure this angle, so this is more than 90 degree na. If it is more than 90 degree, between 90 to 180, then slope will be negative. Now suppose a question comes like this, that this length is suppose 4, from here to here this length is 4, from here to here this length is 3, and they ask what is the slope of this line, correct? So how to solve that I am saying, if they ask what is the slope of this line. So one thing you know, that slope is negative, correct? Why? Because this angle, what you can see, this is greater than 90 degree. So answer will be negative. Now what is the value? So you find tan theta, and what you do now, this is our only theta. Theta we will take this theta. Okay, theta we will take acute angle only. Okay. So tan theta perpendicular by base. So if someone asks what is the slope of this line, so perpendicular, that is 4, base is 3, and also we will add one minus sign because slope is negative, correct? So write this example, very important. So whenever they have given a negative slope line, so just take this acute angle only, this angle only. Tan theta perpendicular by base 4 by 3, but slope will be negative, so I have written minus sign. Okay. Next, suppose we get this kind of curve. This kind of curve we get. Now here they ask you slope. Now whenever, if you want to feel the slope now, that sir I want to feel the slope, then what you think now, that on this line, suppose you are trying to ride a bicycle. Now if you are trying to ride a bicycle, here it will be little bit easy. As you move forward, it will become tough, and here it will be the toughest. So where it is easy now, slope is less, and where it is the toughest, slope is maximum, correct? Suppose we are riding bicycle, road is plain, means slope is less or 0, so it is very easy to ride. But suppose a road comes like this, slope is high, so it will be very tough for us now. So wherever you find it toughest, there slope will be maximum, means here slope will be maximum, here slope will be minimum. Now what we can see, that slope is changing, it is not constant, correct? Slope is not constant. I told you here it is easy, here it is tough to ride. So slope is not constant here. Now suppose someone asks what is the slope, they will give 2 points. Suppose here we have 1 point here, and they give, suppose here we have some different point here. So obviously these 2 points slopes are different. Now how to find the slope, how to feel? One thing I told, that you think that you are riding a bicycle. Another, that what you will do now, you will just draw a tangent to this curve through this point. We will draw a tangent to this curve through this point. Like see, So this is the slope. Now this is the slope. Correct? Now you can feel, see, this line is slopy, but this line is too much slopy. Correct? So always you have to visualize. So at any point if they ask what is the slope, just draw tangent to the curve passing through the point. Correct? Definitely, see, we can see here slope is too much, here slope is less. Correct? Now this is just to feel what is the value. Okay, value of the slope. So for value only, like we are studying this derivation and all, we have a special tool called derivation, which I did yesterday, the formulas and how to do the derivation. Okay, its use is here, that okay, we are studying derivation, dy by dx of x square 2x, x cube 3x square, but where is its use in physics? Why we are studying? Because that is a part of mathematics. Just to, for these cases, that they gave, the scientists did a lot of work and they gave a concept that if you have to find a slope passing through a point to a curve, then what we can write now, that slope is like slope here. Suppose slope is, suppose this is y versus x curve, so we can write slope equals to dy by dx. Correct? Now this point must be having some x coordinate. Suppose this is x1, so we will write dy by dx at x1. Correct? Similarly here, this point must be having some x coordinate, x2. So here someone asked what is the slope, so dy by dx at x2. Correct? So this is the application of derivation. So write this formula for slope is dy by dx also. Like see, suppose this is y versus x graph and there is a curve. This is a curve, suppose, and this curve is what? Y equals to x square. Like we have one equation, y equals to x square. If they ask you, so you will make points and you will like join these points, you will make one curve. So this is the graph of y equals to x square. If they ask what is the slope at this point and what is the slope at this point, so slope is, see, slope general formula is what? dy by dx, dy by dx. Now you have studied, see, if y is equals to x square, this was the curve, na? So our dy by dx will be, dy by dx will be what? 2x. X square differentiation 2x. So if someone asks what is the slope here, so you will ask her, tell me what is the x coordinate here. Suppose I say that x coordinate is 4. X coordinate is 4. So you just place 2 4s are 8. So here slope will be 8. Someone asks what is the slope here, so here slope value will be 8. If someone asks what is the slope here and this coordinate is x equals to suppose 7. So slope is what? 2 into x, slope is dy by dx and dy by dx is what? 2 into x. Here what is the x value? 7. So 2 7s are 14. So here slope is 14. And you can clearly see here slope is 8, here slope is 14, here slope is more. See? So you write this, if you don't skip this basic mathematics, this is very important. Okay, this will help you. These are the mathematical tools which will help you in physics. Otherwise your answer will come and in the last step you are not able to write the exact answer, exact solution, even if you know the answer. So these are very important. So slope formula one formula is what? Tan theta. Means if there is a line and they have mentioned some angle, so directly slope tan theta. Slope, another formula is what? Dy by dx. Acha, if we have P versus T graph, suppose some graph is there, I am not drawing, and now if I ask what is the slope, so general formula is dy by dx if the graph is y versus x axis, but here the graph is P versus T na, so here slope will be dP by dt. In place of y we have P, in place of x we have T, so dP by dt. Similarly, if we have V versus T graph, so slope will be what? dV by dt, dV by dt. Okay, the slope of this graph will be dV by dt. Next, suppose, see, this is y, this is x. Suppose my graph is like this. Correct? This is my graph. This is some expression. I don't know like any curve. Y equals to suppose x cube something like that. So the equation I am not exactly interested. What I try to make you understand that here you can see two important points. One is this point. Here, what is the speciality of this point? Here graph y is having maximum value. See, this is y maximum. Correct? And here, this point. Here y is getting the minimum value. So this is basically y max, we can write. And this is y minimum. So here we are getting the maximum value of y, here we are getting the minimum value of y. So at some value of x, we are getting maximum value. Similarly, at some value of x, we are getting minimum value. X dash you can write. So at x you are getting the maximum value. At x dash you are getting the minimum value. Okay. Now you can see at both these points, if I draw the slope, here also if I draw the slope is like that. Here also if I draw the slope is like this. So at both these points what you can see, slope is 0, there is no slope. Slope value becomes 0, see na, horizontal, this line is also horizontal. So whenever you get maxima and minima cases, maxima value, minima value. So for maxima and minima always remember that slope here also it is 0, see slope what we are getting 0. Here what we are getting, slope value is 0. And what is slope? dy by dx means dy by dx is 0. Similarly dy by dx 0. So at both these cases, that at maximum case and minimum case, dy by dx value has to be 0. Always understand. So we studied now in gravitation chapter or in electrostats, where we will get the maximum electric field. We had not these cases, that ring r by root 2, where we used to get r by root 2. How we get? So electric field is having some formula. So maximum value we will get, we will just differentiate and we will put 0. dy by dx has to be 0. Correct? So always remember For maxima and minima cases, maxima and minima cases, dy by dx equals to 0 or slope equals to 0. Like for example, I will take, like there is a ring whose charge is q, its radius is r. Just example. So those who can remember, they can correlate. So there is a ring whose charge is q, whose radius is r. At some small distance r or x whatever, at some small distance r, small r, we have field formula. Do anyone remember this field formula? KQ
x upon 2 into r square plus x square the whole power 3 by 2.
KQX. Okay, KQR, r square plus r square to the power 3 by 2.
Into
2 was also there. No. ये तो small mistakes can create. You once check. I am just telling the importance of dy by dx. Okay. So suppose this is the formula. Whatever be the formula. Okay, 2 is there. Forget that. Concept I will tell. But you once check. Okay. So KQR, r square plus r square to the power 3 by 2. Now this is general formula of field. They can ask what is the field here. So r value 0. Now they are asking now at any point in this path, there is a point where field is maximum, where this electric field is maximum. So maxima case came na, and we have learned that for maxima dy by dx has to be 0. So we have learned that for maxima minima, that slope or dy by dx has to be 0. Now dy by dx has to 0, like if our equation is like y equals to something x square plus x whatever, x square 5x like this. But here we don't have y and x na. Here we have, you think like this is y equals to something. You have to see which is variable. This k is constant, this q is constant, this capital R is constant. These are not variable. Okay. See, you have to see which are variables. Like you people, I understand that you people find which is variable, how that, what we will write, dE by dq we will write, or dE by dk we will write, or dE by d capital R we will write, or dE by small r we will write, dr. You have not this problem. So see, basically if we write dy by dx, both these are what? Variable. Y and x are variable. Here what are variable? See, this is constant. So this capital Q is also constant. This capital R is also constant. These are fixed values, na? So if you change R, this will change. Means this is Y, this is X. Because all other things are constant. So here what we can write, dE by dr, small r has to be 0. Because they are asking the maximum, that when we will get, where we will get field maximum. So dE by dr has to be 0. Now if you solve this, if you differentiate this, you will get r equals to plus minus r by root 2. Means application I am just telling. Okay. So there is one equation like y equals to x cube by 3 plus x square by 2 minus 6x. Okay. So this is our equation, y equals to x cube. This example if you understand now, you will solve most of the questions. Y equals to x cube by 3 plus x square by 2 minus 6x. Okay. Question is, you have to find like minimum value of y and maximum value of y. Okay, you have to find y minimum and y maximum, or they can ask differently also, at what value of x you will get y minimum, similarly at what value of x you will get y maximum, where you will get y minimum, where you will get y maximum. So how to solve? First of all, they are talking about minimum and maximum values, means our dy by dx has to be 0. So what we will do, that we will write dy by dx has to be 0. So differentiate dy x cube differentiation 3x square by 3 plus x square differentiation 2x by 2 minus 6. So 3 cancel, 2 cancel, so x square plus x minus 6. This has to be, this is dy by dx, this has to be 0. This is the same equation that I gave yesterday. You can solve by factorization also or discriminant method. X square plus 3x minus 2x minus 6. So x plus 3 minus 2 x plus 3. So what roots we got? See, we got x equals to 2 and x equals to minus 3. You can check, yesterday we did. Correct? Now the problem is, see, here you will get 50% of the answer, but you got two values of x equals to 2 and x equals to minus 3. See, one of the value, if you put one of the value, you will get maximum value of y, and if you put another value, you will get minimum value. Okay, now there are two methods to do, because they are asking that at what x you will get max. Suppose the question is at what x you will get the maximum value of y. Now you are getting two values of x, so do hit and trial. X equals to 2 you put here and see what value you are getting. Similarly, x equals to minus 3 you put here and see what you are getting. If you are getting more, so that is the maximum value. If you are getting less, that is the minimum value. But it will take many times. See na, if you put and then solve, then again if you take minus 3 and you then solve. What I again I am saying, you got two answer. This is one of them and this is another. Out of them, one is point of maxima and the another is point of minima. So how to find point of maxima and point of minima? So point of maxima and minima, how we find? See, what I am saying, that when I did dy by dx equals to 0, I got two values, one value like x1 and another value x2. That x1 is what? You can take, one is 2 and one is minus 3. Now out of them, one of them is maxima and one of them is minima. We don't know which one is maxima and which one is point of minima. So what we have to do? Differentiate once more. Means again you differentiate d2y by dx square. Okay. Don't fear by looking these 2y and all. This is just another differentiation, d2y by dx square. If you are getting greater than 0, so that is a point of minima. Point of minima. And if you are getting less than 0, so that is a point of maxima. First you write, I will tell. If you get positive, that will be point of minima. If you get negative, that will be point of maxima. So this is just mathematics. How it is happening, let it go. Just you remember this step. Now see, come back to the question. You are getting two values of x equals to 2 and x equals to minus 3. And this is our dy by dx. What was our dy by dx? dy by dx we solved now, x square plus x minus 6. This was our dy by dx. See, I am writing. Our dy by dx, x square plus x minus 6. This was our dy by dx. And we have got two values. One is x equals to 2 na, and another is x equals to minus 3. Now some people think that x equals to 2, so this is positive, so point of maxima. This is x equals to minus 3, negative, so minima. No, it is not like that. Okay, we have to follow the process. Process is differentiate once more, d2y by dx square. If I differentiate this once more, so x square differentiation 2x, x differentiation 1, minus 6 differentiation 0. So what we are getting? 2x plus 1. Now you check with these values, like I will put 2. So if I put 2, so 2 to the 4 plus 1, 5. So if I put x equals to 2, what I am getting? This value, this 2x plus 1 is coming out to be 5. So this is positive na? Positive means it is a point of minima. Positive means, see, if d2y by dx square is greater than 0 means positive, less than 0 means negative. So if this is positive, that will be a point of minima. Means x equals to 2, this is a point of minima. Point of minima. So see, clearly if this is point of minima, this will be what? Point of maxima. Point of maxima. I mean, you can check also, see, you check this point separately. 2x plus 1, you put x value minus 3. So minus 3 into 2, minus 6, minus 6 plus 1, minus 5. So you are getting negative. So if you are getting negative, that will be point of maxima. So they were asking, actually the question was that find the minimum value you have to tell. So you can tell, see, y minima you know that you will get at x equals to minima value, where you are getting at x equals to 2. You are getting at x equals to 2. Let's solve. You put x equals to 2. Y value you will get 2 cube, that is 8 by 3 plus 2 square 4 by 2 will be 2 minus 6 to the 12. So this will be, okay, just approx I am doing. So this will be 2.6, 3 to the 6, 23, 6 18, okay, plus 2 minus 12. So 2 plus 2, 4.6, 5, 7. So y, correct, minus 7.4. So this is the minimum value, this is the y minimum. And maximum value you will get, what is the point of maxima? X equals to minus 3. X equals to minus 3 is the point of maxima. So what y value you will get? You put minus 3. So minus 3 cube, minus 27 by 3, minus 9. Minus 3 square, 9 by 2, 4.5. Minus 3, minus 6, plus 18. So 18, 4, 22.5 minus 9. So 13.5. So this is maximum value of y, 13.5, and this is the minimum value of y, minus 7.4. So this is the maximum value. Okay. So this example is very important because it will be used in fluids also, wherever minimum and maximum cases arise. In fluids maximum range, that Torricelli's law we had, now Torricelli's law, where we had maximum range. In this electrostats, maximum field. In gravitation, again maximum field, where you will get the maximum field. Okay, wherever maximum and minimum value question they ask, now you can use this formula. Okay, dy by dx has to be 0. Okay, next is integration. Integration. Okay, so some basic formulas I will tell you. X to the power n integration. So x to the power n plus 1 divided by n plus 1. Example, if someone asks what is the integration of x to the power 5. Okay, so power you add 1, so 5 plus 1 6. Whatever is you are writing here, same thing you write in the denominator. So x to the power 6 by 6. So this is the first formula. Second, integration of sine x. So minus cos x. Integration of cos x, sine x. Integration of e to the power x, e to the power x only. Integration of 1 by x, log of x. Integration of x, x square by 2. Integration of dx, x. So these formulas you have to remember. Like one example I am taking. Suppose you have to integrate 2x square minus 5 cos x. You have to integrate this. Okay, now see, they will never give like this, that they will write this and they will write integrate. There is a pattern, there is a format, that whenever you write an application there is a format, na? Date and all these things left side. In our time it was left side, I don't know what is now. Okay, and thanking you, yours faithfully. Although you people are not faithful and respectful, okay, but you will write yours faithfully, yours respectedly, sincerely. So there is a format. So what I am saying, suppose y equals to this, there is one equation, y equals to this. So if they have to write integration, so this is the format, they will write like that, integration of this, like 2x square minus 5 cos x, and if the variable we are dealing with x, so here dx. See, if you go in mathematics, we have different variables also, but simple cases, just for like your exam purpose I am telling. Okay, so you will get like this. So this is the format. Okay, like if they want to ask what is the integration of x cube, suppose, so they will not give like this, that tell me fill in the blanks. So it will be like this, integration of x cube dx. So this is the format. This kind of thing, this is called integration, and the variable is x, then they will write dx. Suppose they ask you to integrate suppose 5 t to the power 1 by 2. This they want you to integrate, so they will write like this, integration of 5 t to the power 1 by 2 dt. Here the variable is t, so dt. Correct? This is the format. Now let's find this answer. Okay. For this, see, one basic I will tell. Suppose a plus b multiplied by c. Here we have situation like this, a plus b multiplied by c. So what we do? A multiplied by c. So what we write? A multiplied by c. Then there is plus. So we will write plus. Then b multiplied by c. This is the basic. Similarly here, first this term will multiply by dx. Okay. So I will write integration of 2x square dx. Correct. Then there is minus sign. Then there was minus sign. Then this number will be multiplied by this. So integration of 5 cos x dx. Correct. Now see what to do. Here see, 2 always constant you take outside. So constant is outside. X square integration, power you add 1, x cube by 3. It will be what? X cube by 3 minus 5 again you take out. Integration of cos x.
Cos x, sin x.
Sin x. Integration of sin x is minus cos x. Integration of cos x is what? Sin x. Integration of cos x is sin x. So minus was already there, that's why I have written minus. Okay. So this will be the answer. See, sin x minus cos x, but cos x integration sin x.